is we're going to move on to chapter 2. And we just started the October month. We got 3 skills that we're going to do in this next section. So 2A is conditional statements, 2B is counterexamples, and 2C is algebraic proofs. So we have now entered into the new chapter with proofs. I will tell you that some students can get extremely confused with proofs. They're not cut and dry. They're kind of a logic thing. So if you're experiencing trouble, make sure that you come in as soon as you can, okay? And don't get behind. All right, let's take a look at our first slide, and I'm going to ask you to stay with me. Try not to go ahead because on top of looking at definitions, I'm going to look at examples and we're going to pull stuff out, okay? And I see some people going ahead already. Please do not go ahead. Please follow with us, okay? So first of all, we're going to look at one definition. It's inductive reasoning. So there's 2 types of reasonings. There's inductive and deductive. Today we're going to look at inductive. Inductive is a type of reasoning that allows you to reach conclusions based on a pattern of specific examples or past events. Main idea here, and I'm going to underline it for you, is a conclusion based on patterns. So I'm going to look and take a look at what has happened in the past, and take a look at all these patterns, and I'm going to make a conclusion. I'm going to make a decision, okay? So let's take a look at the first example. Here's one type of example. It says, find the next numbers in the sequence. So what would be the next number in this sequence? A. Yes. Not 12, but 11. Thank you. Yeah, so it's 11, and what did you do to get 11? So they're odd numbers. Or we could say, yes, add 2. Yep. And that would be fine. We went by odd, so 1, 3, 5, 7, 9, 11, or add 2. Both of them are correct. Okay. Let's move on and let's look at B. So what would be the next number in this sequence? 48 is correct. How did you get that? Good. Multiply by 2. So you're going to notice that the first 2 are really simple. My numbers are getting bigger. I'm either going to add or I'm going to multiply, right? Let's keep going. This one's a little bit more complicated in that it's not quite so cut and dry. The next number will be you might need a calculator. Notice that my numbers are getting bigger, so I'm probably going to do some either addition or some multiplication of some sort to be able to get that next number. Yes?
It's adding by 6 and 6. I mean, it's adding by, never mind.
Okay, sorry. Anyone figure it out?
Oh, yeah.
Okay.
14, 28, 48.
Okay, so you said I'm going to add by 7. I'm going to add by 14. We can add, but it's not consistent. We can add by multiples of 7. Is that what you're saying? Okay, so I can add multiples of 7. Did anyone else come up with a different pattern? Because there is another one. Yes.
So you start with 7 and then you multiply that by 2, which gives you 14. And you multiply that by 2, which gives you 28. And then you multiply that by
So you're saying that the change, so in other words, you said this is 7. So to get the next one, I'd multiply 7 by 2 and I get 14. And then I multiply 14 by 2 and I get 28. Okay. It's another way of doing it. Did you find another one? There's another one that's more of a formula. You're right, these are patterns and they do work, but can you find a formula that would always work, like a function machine where I put a number in and I get another number out? Like, what do I do to 1 to get 8? What do I do 8 to get 22? What do I do to 21 to 22 to get 50? Like, what would be the formula? What would be the process? And it's always the same. You find it? What would be the end number here? What's the number on the end of the pattern? Even if you use the other one, what would it be? It's 442. That is correct. That is your number. Did you find the other pattern? Like a function machine? I can multiply by 2 and multiply by 2 and, yep, add 6. Yep, that's a function machine. You can do that. You could even set up an equation like y equals 2x plus 6. And we actually did that in algebra. Okay? That's not bad to look at the pattern as multiples of 7. That totally works. However, we need to move to the next step on trying to find an equation and what would work for every single number. Okay? All right, let's move on. A conjecture. Here's another definition. A conjecture is a conclusion reached by inductive reasoning. So it's coming up with that last number. It's what is your reason behind what we did. So let's take a look at an example. It says draw the next picture in the sequence. So in other words, I've got my square and then I got my triangle in my square. What would be the next thing in the sequence? I would, yep. I'm going to put a triangle there. So I'm going to draw my square, and then I got my triangle, and then I have my square, and then I'm going to draw another triangle. Now, some of the pictures that you're going to be drawing for me are not going to be, they can be kind of difficult. Just do your best, okay? I know some students earlier today were struggling with trying to draw a cube, right? Just do your best. I understand that some of you might not be able to draw some of that stuff. If you have trouble with it, ask me, because I've got some tricks that will help you with that. All right, here's another example. If you add 5 more rows to this picture, how many small triangles would you have altogether? Now, my question is this. If you were taking an ACT exam, would you really want to draw 5 more rows on this thing? No way. It'd be way too hard. So if you remember patterns back in algebra, do you remember how we did something like this? Like, how did we arrange numbers? Do you remember? We looked at patterns. How did we do that in algebra? Okay, maybe this will help you. XY table, right? We're going to look at a table. And over here I've got number of rows. Here I have number of triangles. And it's going to help us with this. Okay? So I'm going to take a look at the number of rows. I'm going to look at the first row right here. And I have 1 triangle. Then I'm going to look in row 2, and how many triangles do I have in that row? 3. Yep. Okay. The third row, how many triangles? 5. Fourth row, how many triangles? 7. Okay. I don't know any more. So rather than drawing, it says I've got to come up with 5 more rows. So there's row 5, 6, 7, 8, 9. Now, take a look at the pattern. What is the pattern that's taking place? Yes. Yep, so I'm adding 2. So, what do I get for the next blank? 9. 6th row, how many triangles? 11. 7th row? 13. 8th row? 15. 9th row? 17. Did I answer my question? I did not. Why not? Yes. It's asking me how many small triangles do we have all together, right? So I need to find my total, and you said you were going to do it how? Add them up. Yep, so go ahead, add them up. How many triangles do I have there? Yes, sir. 81. So 81 triangles. A lot easier to make a table than sit there and draw all those out, right? And then you have to count them all up. All we had to do is add that column. Okay, so using our algebra, using our input, our output, our t-table, using those items is really going to help you. All right, let's move on. Here's a world problem, and they actually do stuff like this with statistics when they're looking at businesses, like how long should the hours be of the ice cream store downtown? Like, how many customers do we have? How much ice cream do they sell? What should the hours be? When is it going to be worth us to be open due to how many customers we're going to have? Okay. So this example is a rollerblade shop, and it discovers that over the 5 consecutive months, the rollerblade sales have decreased. Using inductive reasoning, make a conjecture about how many rollerblades they will sell in August. Notice that we've got some words in here. Okay. A lot of times in the problems on the ACT, it's not so much you don't know how to do the problem, you don't know the verbiage as to what they're asking for. So you're going to notice that they have inductive reasoning, and you'll notice they say conjecture. Okay, what they're saying is let's look at these patterns and let's find out what you think. What do you think it's going to be in August? So to do this, what we're going to do is we're going to make a table. You'll notice I already started one. So I've got March, there's 110, so I'm going to go like that. In April, I got 80, so like that. In May, I've got 65, so it's about like there. June, it's 59, so about right there. And July, about 45, which is about there. And again, I'm doing it on an iPad, so it's a little bit more difficult to, find the exact location. But in algebra, what did you do to be able to make projections based on dots? Do you remember? I know you did this in 8th grade. What would you do to be able to decide what's going to happen in August? And August is right here. Do you remember what you did? Yes.
Find the slope.
You did use something with a line. That's right. You can find the slope or find the equation of the slope, and it's called the line of best fit. So what you do is you try to draw a line that kind of goes in the middle. It's called the line of best fit. And then you make a projection based on that. That's not my favorite line. Let's make this a little bit better. There, that's a little bit better. So you try to, that's like a scatter plot, and then what you do is you draw a line kind of in the middle of it, and then what we're going to do is we're going to make a projection. So I'm going to go up from August, I'm going to hit that line, then I'm going to go across. So how many rollerblades do you think we're going to rent? Based on our scatter plot. Yes?
About 30.
I got a little less than 30. I got around 25. So about 25 roller blades. I got about 25. Now, one person asked me earlier today, well, Mrs. Medvick, what happens if I'm a little bit off? You'll be fine if you're a little bit off. Again, it's a line of best fit. So it kind of depends on how you get that line in the middle of your data. Okay. Questions? Okay. Question, are all conjectures true? If I look at a pattern, will that always be true? Well, it's raining today. It's been raining the last couple of days, so I'm going to say that tomorrow's going to be rainy. Is that true? Not necessarily, right? So not all conjectures are true. So let's take a look at one like this. It says number of points. So what they're getting at when they say number of points, they're saying here's a point and here's a point. And it's saying how many regions. So like this is an empty spot and this is an empty spot. So this is 2. And then it says 3 points. So there's 1, 2, 3. And I've got 1, 2, 3, 4. So there'd be 4 there. Okay, let's look at the next picture. There are how many dots? I got 4. 1, 2, 3, 4. There's 4 dots. They connected them. How many regions are there? There's 8. Okay, so based on my pattern, if I had 5 dots, how many do you think we'd see? Yes, we think 16 because it says to multiply by 2. So for 6 points, which is the next picture, I should have 32, right? Okay, now take a look at that picture. Notice that I have 1, 2, 3, 4, 5, 6. How many regions do I have? Yes.
Is there 30?
I got 30. Yeah, there's 30 regions. So was my conjecture correct based on this inductive reasoning? It was not. No, it was not. So here's a piece that you need to know. You need only one counterexample to prove my conjecture is wrong. So a counterexample, all that means is one thing that's wrong. So for example, all of my girls in this class have blonde hair. No, not blonde hair. I'm done. All the students in this class are boys. Oh, wait, I see a girl right there, right? So you choose, you find out one way that it's wrong. You can state one fact, and you don't have to, like I don't have to say, but there's a girl, there's a girl, there's a girl, there's a girl. I don't need to do that. All I can say is I see a girl right there, and I'm done. So once you find a counterexample that says, hey, that wasn't true, you're done, okay? So again, what we looked at today was inductive reasoning. It's looking at what? Inductive reasoning is looking at it's a P word. Patterns. We're looking at patterns, right? To make an educated guess, or a conjecture, which is it's a conclusion, right? Is my conjecture always true? It is not always true, okay? All right, so what you're going to do right now is we're going to go into Schoology and we're going to take a look at our assignment.